In this lecture, I'm going to be discussing lights. In Unreal Engine, a light is simply an actor that will generate light for your level. So one thing you should know about lights in the Unreal Engine is that they are not meant to represent the object producing the light, only the light itself. So you don't use a light actor to represent, say, a lamp or a flashlight. You would use a mesh for the lamp or flashlight, and then use a light actor to produce the light itself. Alright, so there are five types of light actors in Unreal. The first of these is the directional light actor. The directional light actor is used to emulate light coming from an extremely long distance away, such as outer space. All the light will hit the level at the same angle, meaning all shadows produced by this light will be parallel. So this actor is used primarily for sunlight and moonlight. Next is the point light. The point light will produce light that emanates in all directions. This is useful for mimicking the light coming from a light bulb or fire, for example. The spotlight, on the other hand, will emit light in the shape of a cone. So this is like the light coming from a flashlight, or as the name suggests, a spotlight, like they use at the theater. The rect light, or rectangular light, projects light out of a rectangular plane. So this is useful for representing any light sources that are rectangular in shape, such as televisions, monitors, smartphones, overhead lighting, etc. The skylight actor is used to emulate the light that gets reflected off of the atmosphere and other distant objects. So when light comes from the sun or moon, a lot of it comes through as direct sunlight or moonlight, and that's what the directional light actor that we talked about earlier represents. But some of that sunlight or moonlight hits particles in the atmosphere or clouds or distant mountaintops and then gets reflected off of those objects at a different angle. So the skylight actor represents that light that gets scattered in the atmosphere or reflected off of other objects and that comes through as weaker indirect sunlight or moonlight at all different angles. In simpler terms, you could say it represents the faint glow of the atmosphere. So one thing you need to be aware of when working with lighting is that you will not see changes to your level affect lighting like they should until you tell the editor to build the lighting. Building the lighting just means that the engine is running a lot of calculations to determine how the light and shadows should now look on objects based on the changes that have occurred since the last time the lighting was built. So building the lighting is easy. All you have to do is go up to the Build menu and select Build Lighting Only. And the reason the editor has you do this manually is because when you start to have many actors and or lights in your level, the build can take quite a while to perform. So even if it only took 10 seconds, you wouldn't want to have to wait those 10 seconds every time you moved an actor in your level. So this allows you to build only when you're ready. So now let's take a closer look at the 5 types of light actors and their properties. Starting with the directional light, which is used to represent sunlight or moonlight. I'm going to drag a directional light into my level, and you can see right away it does render the lighting a bit, but to see the full effect I would need to build again. So with this directional light selected, if I go over to the Details panel, I can view and edit several of its properties. The first of these properties that I want to discuss is the light's mobility. Now I covered this briefly earlier on in the course, but I'll go ahead and go over it again here. If a light is static, that means that not only can it not move, it can't change color or brightness or any other property while the game is running. If a light is stationary, it still can't move, but it can change its color, brightness, or other properties during the game. If a light is movable, it can move and change its other properties during the game. So as you move to the right along these 3 settings, they get more flexible in terms of what the light can do, but they also demand more resources from the processor. So in the light category of the Details panel, there are several more properties of the light that we can edit. The first of these properties is intensity. This controls the brightness of the light. So if I increase the intensity, the light will get brighter, and if I decrease the intensity, the light will get dimmer. The next property is the light color. By default, the color of the light is white, but you can change this if you want. So there are 2 ways to change this light color property. One way is to click on the triangle to the left of it and expand this RGB menu here. With this, I can adjust the amount of red, green, and blue in the light to determine its overall color. So if I wanted a red light, for example, I can remove all of the green and blue, and that will give me a light that is fully red. The second way to edit this value is to click on this strip here that previews the color. This will open the color picker. The color picker is available in several places in the Unreal Editor where there is a need to select a color. The color picker actually gives you several ways in which you can select a color. You can select one from the color wheel. You can adjust the saturation and the brightness using these sliders here. You can set the hue, saturation, and brightness values directly here. This is another place where you can set the red, green, and blue values. And finally, you can use the hexadecimal representation of a color if you wish. Okay, so that's how to set the light color. The next two properties are source angle and source soft angle. These basically affect how soft the shadows produced by the directional light are. The higher the value, the softer the edges of the shadows will be. The default value of 0.5357 for source angle is meant to represent how shadows should look in natural sunlight. And one thing you should know about these properties is that they take advantage of a new computer graphics technology called ray tracing, which is only supported by the latest graphics cards. So if you haven't bought an expensive graphics card or a new gaming computer recently, there's a good chance you won't see any difference by changing these properties. The next two properties relate to the temperature of the light. By default, temperature is not used, but if you want to use it, you can check the Use Temperature property here. And what temperature does is it changes the color of the light based on how hot you tell the engine that the light source is supposed to be. So if you've ever looked at the fire in a fireplace, for example, you will notice it's made up of different colors. Most of it is red, but as you go inwards, it starts to get more orange, and then you may see wisps of purple and blue. The bluish parts are actually the hottest parts of the fire. This may seem counterintuitive as we think of the redder colors as the warmer colors and bluer colors as cooler colors, but as it turns out, if an object gets hot, it glows red, but if it gets really hot, it glows blue. And if it's really, really hot, it will give me a fake phone number when I ask it out. Okay, so as I decrease the temperature setting, the light will shine redder. And as I increase the value, the light will gradually get bluer. Okay, so the next property is Effects World. This simply toggles whether the light is enabled or disabled. If this is unchecked, it will be as if the light isn't even in the level. The next property is Cast Shadows, which determines if the light will cause shadows to be cast when objects block the light's path. So obviously you would want this checked for a more realistic environment. However, shadows are somewhat processor intensive, so if you are in the need of performance savings, you might choose to uncheck this for some of the lights in your level. The next property is Indirect Lighting Intensity. So if some of this light gets reflected off of another surface, that reflected light is called indirect lighting and can also light up objects in the level. This property will determine how much this reflected light affects the other objects it shines upon. Alright, and the last property here is Volumetric Scattering Intensity. This property applies to fog, which will be covered in the next lecture. So when light passes through fog, it will scatter in various directions. The higher the volumetric scattering intensity, the more the light will scatter. Okay, so now let's look at the point light actor. The point light actor emanates light in all directions. It has many of the same properties that the directional light has, with a few additional ones as well. The first of these is the attenuation radius. This determines how far from the source the light will still affect objects in your level. In the level editor, this is represented by this blue sphere here. So the higher the attenuation radius, the larger the sphere will be, and the farther the light will extend from its source. And the lower the attenuation radius, the smaller the sphere will be, and the shorter the reach of the light will be. The next three properties are source radius, soft source radius, and source length. So the light from a point light will actually emanate from a single point in the level. However, let's say I had a light that was supposed to be coming from a long, thin fluorescent bulb, and it was above a very shiny floor. If there was a reflection of the bulb and the floor, you would want it to be in the same shape as the bulb. So you can use these three properties to adjust the size and shape that the light source will appear in reflections. Okay, so now let's take a closer look at the spotlight. The spotlight is very similar to the point light, except that instead of shining light in all directions, it shines it in a specific direction, in a cone shape. So you can see in the details panel that the spotlight has all the same properties as the point light, with the addition of two more properties, the inner cone angle and the outer cone angle. So with the inner cone of the spotlight, the light will be at its brightest and will be just as bright at any spot within the inner cone. From the outer edge of the inner cone to the outer edge of the outer cone, the intensity of the light will gradually fall off to nothing. So you can use the inner cone angle and the outer cone angle to set the size of these cones and determine how much of the light is at full brightness and how much of the light is part of the gradual fall off portion. The next light is the rect light. This actor emits light in a rectangular shape. The first of its unique properties are source width and source height. These are used to represent the size of the light source. For example, a 90-inch television would require a larger source width and source height than a 24-inch television would. The next two properties are barn door angle and barn door length. So if you're not familiar with what a barn door is in the context of lighting, this is what they look like. They are usually used on studio lights, and they help the director or cinematographer or whoever to make subtle adjustments to the lighting by adjusting the angle of the flaps. So you can use the barn door angle and barn door length properties to emulate those kinds of effects. The next property is source texture. So you can actually apply a texture to the light just like you would with a material, and then the light will look as if it's being filtered through that texture. Alright, so finally the skylight. The first property of the skylight under the light category is real-time capture. When this is enabled, actors such as the sky atmosphere and volumetric clouds, both of which we will learn about in the next lecture, these actors will then affect the skylight. So if you're using those actors in your level, you will probably want to enable this property. Alright, so again, the skylight is used to represent the reflection of light from the atmosphere or faraway objects in the sky, such as clouds or mountaintops. And to determine at what distance this light should appear to emanate from, we need to define at what distance the sky should be considered to start at. So by default, this source type property will be SLS captured scene, which just means that the sky will be defined as any point that is the sky distance threshold away from the skylight actor. So if the skylight actor is placed at the center of the level, with a sky distance threshold of 150,000, we are saying that the sky should begin 150,000 units from the center of the level. There's also the option to change the source type to SLS specified cube map and then provide a file called a cube map to define the area that should be considered the sky. However, cube maps are beyond the scope of this beginner's course and won't be covered. Alright, and that will do it for the lecture on lights.